Hello everyone and welcome to a new video. And this video we're gonna start kicking in with differential equations. After the first video, we have discussed the introduction of the differential equation, what a differential equation really is, and now we're gonna try to solve an example. Not quite hard example, but just to know the methods or the way a differential equation look like. Okay, so let's start by taking a real physical uh, equation, which is Newton's second law of motion, which states that force equals mass multiplied by the acceleration. And it's quite apparent that the acceleration happens to be the rate that the velocity changes with respect to time. So it's the first derivative of v, which is for velocity, over time. Okay, and the velocity itself, we can say that it is the change in displacement with respect to time. So it's also the first derivative of displacement or position with respect to time. So we can say that the acceleration itself is the second derivative of displacement with respect to time. And this is actually the acceleration. So we should assume that the force and the mass are constants, and we're going to assume a specific number, any number actually. So we're concerned only here by the acceleration. So A equals F over M. Let's say this equals to 20, anything. So let's start by this, the square x over dt square, which is the acceleration, equals 20. And now we have a differential equation. And actually, it is a order, second order differential equation, and it is actually as well an ordinary differential equation. We have no partial differential derivatives here. So, how to solve this differential equation? We have here dx. We want the solution for this equation for x. We want to solve this for x, but it's actually plugged into a derivative. How we solve this? How we take dx out of this derivative? So we start by the basic rules of calculus, which states that the derivative is the opposite of the derivative is actually the integral, right? So if we want to get dx out of here, we need to have we need to take the integral of this derivative. So we start by integrating both sides with respect to t. It's going to be a function of t. Okay, so here d square x over dt square with respect to t, and we got to integrate this with respect to t as well. Okay, so integrating this side with respect to t, getting us back the first derivative of x with respect to t, and this is going to be so easy. 20 multiplied by t plus a constant, let's say it's constant 1, c1 here. So this is actually a a differential equation as well from the first order. So we haven't solved the problem yet. We have x plugged in a derivative, but we can take another integral here. So we integrate both sides as well with respect to t, which equals, sorry, which which going to equal 20t plus C1 dt, and it is integral as well. By integrating this, the left-hand side, we come to the fact that we took x out of the integral, out of derivative, and it comes out to be x, which equals 20t squared over 2. We know how we integrate, I assume that, and plus C1t plus C2. And this is actually the solution of this is 10, okay? And it's actually the solution for the equation, for the derivative equation we said before, and it's called a general solution. Why is that? Because we have different amount. Let's not say different. It's actually infinite amount of numbers we can plug into this equation and come with a solution. It all depends on the initial positions or initial cases or initial time we start with. So it is actually the general solution. We're gonna dig into the real differential equation. That's much harder or difficult than this in the next videos, but it was like a warm up to start getting into differential equations and know how to solve them, how the process goes. And this is the end of this video. Thank you for watching, and stay tuned for the real big thing coming next. Thank you. Goodbye.